The question is, so why is the time over which the intensity of the source varies related to its maximum size? And you can hopefully understand this from the following example. Imagine that there are three light sources, A, B, and C, separated from each other by a distance of 5 light years. And we are somewhere in this direction, some distance from these three sources. And assume that they are turned on at the same time, right? As if there was a switch that could turn on at the same time all three sources. Now, of course, because source A is closest to us, we will start getting, after some time, the light from it. So if we are at a distance of 100 light years from source A, after we turn it on, we'll get its light after 100 years, right? But we will not see source B, right? Because it takes 5 years for its light to cover this extra distance. So initially, we just first see source A. And then 5 years later, we start getting the light from source B, right? Because it takes extra 5 years for its light to cover this distance compared to the distance that the light from A has to cover. So after 5 years, we see both A and B. And 5 years later, altogether after 10 years, we start observing all three sources, A, B, and C. We are getting light from all three of them. So the light intensity went from 0, before we could see anything, before the light from A could reach us, to the full intensity, the light from all three sources in 10 years. And that is because they occupy range in space that is 10 light years across. Okay? So that is the reasoning, that the time over which the light intensity varies is related to the size of the source of light or radiation. Okay? So that is the reasoning. Okay, so I said that the light intensity has gone from 0 to the maximum value in 10 years because the size of the total source, which is A plus B plus C, is 10 light years across. So from the fact that the intensity of radiation from Seyfert galaxies varies on the scale of minutes, we conclude that the size of the source responsible for radiation cannot be bigger than few light minutes, which is comparable to, say, 1 astronomical unit.